Good morning, good afternoon, good evening, mammals. This video is for NTI Day 14, Tuesday, March the 31st. It's actually going to take us the rest of this week out because it's the first topic in our next unit, and I don't really have enough time to get into the second one before spring break. So it'll sort of allow some of you guys that are a little behind to play catch up on the NTI because we're not really going to be moving forward with that much new material. So short set of notes today to show you how to solve these problems and a couple online practice sets, and that's going to do you guys for the week. So this new unit is on reactions, and I'm really bummed that we're not at school doing this because this is where most of the hands-on stuff in the class comes, so it sucks, but it is what it is. So what we're going to start with today is how to solve a kind of a problem that we say is balancing a chemical equation. So here's a chemical equation that I have balanced, and on the left side are what we call the reactants, and on the right side are what we call the products. And this arrow here, I want you to think of it as an equal sign because chemical reactions have to obey the law of conservation of mass. So we have to have the same number of each atom on both sides of the reaction. And we do that by looking at two numbers. Subscripts, these little numbers here, if they're not shown, they're assumed to be 1. And they apply only to the element that they're attached to. This 4 applies only to the hydrogen. This 3 applies only to this oxygen. And coefficients, which are numbers out in front, which distribute to everything in that compound. So this 2 distributes to the nitrogen, the hydrogen, the iodine, and the oxygen. And this 4 distributes to everything in this compound. It distributes to the hydrogen and to the oxygen. It doesn't distribute to these other compounds. Just like in math class, if you have a plus sign, the coefficient doesn't go across the plus sign. It only goes to the term that it's attached to. So if we look at this real quick, we can see that this is a balanced equation because on this side I have 2 times 1, so I have 2 nitrogens. I have 2 times 4, so I have 8 hydrogens. 2 times 1, 2 iodines. And 2 times 3, 6 oxygens. And on the other side, I have 2 nitrogens. I have 4 times 2, 8 hydrogens. 2 iodines, and 2 oxygens here, plus 4 times 1, 4 oxygens, gets me a total of 6 oxygens there. So the balance means that all told on this side, I have the same number of each kind of element as all told on this side, so just an equals arrow. So what you'll be doing is you won't be touching the subscripts, you'll be adding coefficients to an unbalanced equation to make it happen. And these are kind of like a jigsaw puzzle. There's lots of different ways that you could put together a puzzle. You don't have to put it in the same order that I do, but there are some strategies that will help you get it done a lot faster, like starting with the corners and building the edge, and then filling in the middle. So I'm going to give you some pointers. You don't have to do these to solve these problems, but it'll make sure that you solve the problems in the most efficient way possible. So your first one is you're not allowed to solve these by changing a subscript. I could look at this and I could say, aha, I have 2 hydrogens. I have 2 hydrogens. That's balanced. I have 2 oxygens. I have 1 oxygen. So I might be tempted to balance it by slapping a 2 on this. Now this is a legit chemical reaction because this is hydrogen peroxide. However, it's not the chemical reaction that the problem asked you to solve. So you would have to do it by adding coefficients rather than adding subscripts. So we would balance this one by putting a 2 here. That was a sloppy 2. A 2 here. And that distributes to this oxygen, giving us 2 oxygens to match the 2 oxygens here. It also distributes to the hydrogen, giving us 4. So I would need to put a 2 here also, so that I have 4 hydrogens. And this one, I didn't have to change anything, so it's just a 1. Second tip is kind of what you saw me doing to solve that previous one. I'm going to choose one element to focus at a time. I'm not going to try and solve the whole problem. So I'm going to start with sodium. I have 1 sodium. I have 1 sodium. They're balanced. Move on to the next element. I have 2 chlorines. I have 1 chlorine. So I have to put a 2 here, which balances my chlorines, but it upsets my sodium. So I'm going to have to go back and think about my sodium again to make there be 2. So try and focus on just one element at a time. That comes natural to a lot of people. This next tip, though, is for helping you solve more difficult problems. If an element is in more than 2 compounds, you need to do it last. And so I look at this one. Oxygen is here, here, and here. So the reason we're going to save it for last, because if I need to change my oxygens, which one do I need to change? Do I need to change it in this compound, or do I need to change it in this compound? So we want to do it last. That way we've pinned down all of the other elements, and then that'll give us a clue as to which one we should change. So for this one, you should start with either the carbon or the hydrogen. Doesn't matter, as long as you save the oxygen for last. So here I have 3 carbons. So I want to come over here and put 3 carbons. And I have 8 hydrogens. So I have to think about what times 2 will give me 8. I'm going to put a 4. Now I'm ready to think about my oxygens. On this side I have 2. On this side I have 3 times 2, that's 6 oxygens there. And 4 times 1, 4 oxygens here for a grand total of 10 oxygens. Now I can come back and think what times 2 gives me 10. I put a 5. And so that one would just be a 1. Very last tip for the hardest kinds of problems that I'm going to give to you is occasionally you'll get into a situation that I call even and odd. And what you're going to do is double everything, because if you double any odd number, it'll become an even number. Let's look at this one and see how that helps. Again, I'm going to stay away from the oxygen, because oxygen is in more than 2 compounds. I want to do either the carbon or the hydrogen first. This one didn't get changed. I'm sorry. This example should say C2H6 plus O2 goes to CO2 plus H2O. Otherwise, it's exactly the same as what I just did. Now I'm going to start with my carbon. I have 2 of them, so I'm going to put a 2. I have 6 hydrogens, so what times 2 gets me 6? 3. Now I'm going to total up my oxygens. 2 times 2 is 4. 3 times 1 is 3. So I have 7 oxygens on this side. When I come back to this side, I have 2. There's nothing I can multiply by 2 to get me 7. So here I have an even, and on this side I have an odd. So what I'm going to do is I'm going to double everything that I've already changed and start again. I want to make this 4 CO2s and 6 waters. when I look at this, I have 4 carbons. So 2. 2 times 2 is 4. And that also works out for my hydrogens. 6 times 2 is 12. 2 times 6 is 12. Now let's see if it'll let me wrap this problem up with the oxygens. 4 times 2 is 8. 6 times 1 is 6. So that is 14 oxygens. What times 2 gives me 14? A 7. And now it's balanced. So the very hardest problems you'll run into, you'll have an even and an odd number, and you'll need to double it. Occasionally, you'll have to do this process like 2 times or even 3 times, where you still have something that's odd when you go back and balance it, and you have to double that again to turn that odd number into an even number. So I'm going to close with the 2 activities that I've linked to. The first one, yeah, someone was feeling special when they named this website Fun-Based Learning. But it's a good visual way to do it because it shows you representations of everything. What you should do in the beginning is make everything one, so it populates at least one picture. And now I can visually see what's balanced and what isn't balanced. I can see that I have 2 hydrogens and I have 1 hydrogen. So I need to change this to a 2. And when I do that, it'll make a second one of these images pop up. And now I can see that my hydrogens are balanced because I have 2 hydrogens and 2 hydrogens. I can also see that my chlorines are now balanced, 2 chlorines, 2 chlorines, and I can come up and click this button and it'll say balanced. The last one on this set, problem number 11, is a real doozy. So if you need some help on that one, just hit me up on Remind or something. That one is very, very challenging, and I'll give you the key to help you get it solved. The next activity is on PhET. You're going to play the game. There's 3 different levels, and this works in a similar way. Start everything, that's not my pointer, start everything off with 1s, and it'll populate little pictures so that again you can see what's balanced and what isn't balanced. I can see that I have 1 blue here and 2 blues here, so I would need to change this one to a 2. When I do that, it's going to make another little guy pop up, and now I can see that this situation is balanced. 2 blues, 2 blues, 2 oranges, 2 oranges. Click the check button and it gives you the smiley face +2 to know that you're done. So this activity will take you out through the rest of this week, and you can submit screenshots of your score on both of these. You can earn some bonus points with the PhET one. If you get into the higher bonus level, just see my minimum scores on the Google Classroom. And if you have any difficulties, you can hit me up on email, Google Classroom, or Remind. And as always, take care of yourself and others, practice good hygiene, and I'll see you on the flip side.